W17_Ms_41. 3. When magnesium is added to aqueous copper sulfate, a reaction occurs. The ionic equation for the reaction is shown. Give one change you would observe during this reaction. Brown-orange solid forms is made. OR solution becomes paler, colorless. Explain why this is a redox reaction. Magnesium is oxidized and copper ions are reduced OR. Magnesium loses electrons and copper ions gain electrons OR. Magnesium increases in oxidation number and copper decreases in oxidation number. Identify the oxidizing agent in this reaction. Give a reason for your answer. Copper 2 ions OR copper ions 1. Gains electrons 1. IV. A redox reaction occurs when magnesium is heated with iron 3 oxide. Write a chemical equation for the reaction between magnesium and iron 3 oxide. B. The metal iron and the alloy steel are commonly used materials. A problem with them is that they rust. How does painting iron and steel prevent rusting? Prevents air, oxygen and water from reaching the steel. Magnesium blocks can be attached to the bottom of steel boats. Explain how the magnesium blocks prevent the whole of the bottom of the boat from rusting. Magnesium is more reactive than iron, steel 1. The magnesium corrodes before the iron, steel. OR. The magnesium corrodes preferentially. Replacing the magnesium blocks with copper blocks does not prevent rusting. Explain why the copper blocks do not prevent rusting. Copper is less reactive than iron, steel. 0620_S17_Ms_41. 4. Zinc is a very important metal. Zinc is extracted from its ore. Zinc blender. Zinc blender contains zinc sulfide, ZNS. Zinc sulfide is converted to zinc oxide in an industrial process. Describe how zinc sulfide is converted to zinc oxide in this industrial process. Roast in air. Write the chemical equation for this reaction. B. Zinc oxide is then reduced in a furnace. Name the substance added to the furnace to reduce the zinc oxide. Coke. Describe how the pure zinc is removed from the furnace and collected. Zinc is vaporized, boiled 1. And is condensed. C. When rods of zinc and copper are placed into dilute sulfuric acid as shown, electricity is generated. Write the ionic half equation for the reaction occurring at the zinc rod. Write the ionic half equation for the reaction occurring at the copper rod. The copper rod was replaced by an iron rod. Suggest the change, if any, in the intensity of the light emitted from the bulb and give a reason for your answer. Change. The intensity would decrease. Reason. The difference in reactivity between zinc and iron is less than the difference in reactivity between zinc and copper. Total. 12. 5. The diagram shows a simple cell. The simple cell was used with different metals as electrodes. The voltages were recorded in the table. Filled circle. If the voltage measured is positive, then metal 2 is more reactive than metal 1. Filled circle. If the voltage measured is negative, then metal 1 is more reactive than metal 2. Filled circle. The more reactive metal is oxidized. Filled circle. The bigger the difference in reactivity of the metals, the larger the reading on the voltmeter. In a simple cell using nickel and silver, the nickel is oxidized. Define oxidation in terms of electrons. Loss of electrons. Nickel forms ions with a charge of +2. Write an ionic half equation to show the oxidation of nickel. What will happen to the mass of the nickel electrode when the nickel is oxidized? Goes down, gets less, decreases, lower, smaller. B. Use the data in the table to answer the following questions. Which of the metals in the table is the most reactive? Explain your answer. Beryllium. 1. Most negative voltage with any named metal or biggest voltage with cobalt, nickel. State which two different metals have the same reactivity. Cobalt and nickel. Predict the voltage produced by a simple cell with beryllium as metal 1 and silver as metal 2. Sign 2.7. C. Describe how the simple cell in the diagram can be used to show that magnesium is more reactive than beryllium. Explain your answer. Set up cell using magnesium and beryllium electrodes. 1. Voltage positive if magnesium is metal. OR set up cells using both magnesium and beryllium with the same metal as the other electrode. Larger magnitude voltages with magnesium 1. OR use magnesium with a different metal and compare to a reference value in a table 1. Value is more negative than with beryllium, if magnesium is metal 1. 0620-S15-Ms-32. 3. Calcium reacts with nitrogen to form the ionic compound calcium nitride. Draw a diagram, based on the correct formula, which shows the charges on the ions and the arrangement of the electrons around the negative ion. Use O to represent an electron from a calcium atom. Use X to represent an electron from a nitrogen atom. M1 both correct charges of ions calcium 2+ and nitrogen 3. M2 8 electrons around nitrogen can be 3 dots and 5 crosses or 5 crosses and 3 dots or all crosses, but reject any other combinations of dots and crosses. M3 2 electrons on the inner shell on any nitride ions nitrogen atom, allow 2x or 2O once. B. In the lattice of calcium nitride, the ratio of calcium ions to nitride ions is 3:2. What is meant by the term lattice? Regular, repeated pattern, framework, periodic, ordered, alternating, organized. Of particles, atoms, molecules, ions, cations, anions. II. In terms of ionic charges, explain why the ratio of ions is 3:2. So that ionic charges balance or cancel. Charge equals 0, no charge. Number of positive equals number of negative charges. Charge is neutral or neutralized. 3 times 2 equals 2 plus times 3. C. The reaction between calcium and nitrogen to form calcium nitride is a redox reaction. In terms of electron transfer, explain why calcium is the reducing agent. It refers to Ca. Calcium Ca atom loses, gives, donates electrons e.e. These are gained by nitrogen Nn2. Nitrogen Nn2 is reduced, so calcium Ca is the reducing agent. These two statements could be split, i.e. not in same sentence. OR reducing agents or electron donors give, lose electrons. OR calcium Ca is oxidized by electron loss, therefore calcium is the reducing agent. These two statements could be split, i.e. not in same sentence. 0620-S12-Ms-31. 4. Vanadium is a transition element. It has more than one oxidation state. The element and its compounds are often used as catalysts. Complete the electron distribution of vanadium by inserting one number. 2 plus 8 plus 2, 2 plus 8 plus 11 plus 2. B. Predict 3 physical properties of vanadium which are typical of transition elements. 1 hard, 2 strong, high tensile strength. 3 high MP, BP, high fixed points. 4 high density. C. Vanadium V oxide is used to catalyze the exothermic reaction between sulfur dioxide and oxygen in the contact process. The rate of this reaction can be increased either by using a catalyst or by increasing the temperature. Explain why a catalyst is used and not a higher temperature. Catalyst would not affect yield. Change position of equilibrium affects both sides equally. 1. Higher temperature would reduce yield. Increase in temperature would favor back reaction. D. The oxidation states of vanadium in its compounds are V plus 5, V plus 4, V plus 3, and V plus 2. The vanadium 3 ion can behave as a reductant or an oxidant. I indicate on the following equation which reactant is the oxidant. V3 plus is oxidant. II. Which change in the following equation is oxidation? Explain your choice. V3 plus to V4 plus. 1. Increase in oxidation number, electron loss. 0620-S10-Ms-33. 3. The following are examples of redox reactions. Bromine water was added to aqueous sodium sulfide. Bridge 2 Aq plus S2 Aq, right pointing arrow to bridge Aq plus S's. Describe what you would observe when this reaction occurs. Red, brown or orange to colorless 1. Not just bromine decolorized yellow, not dark white solid precipitate goes cloudy 1. Brown to yellow with no mention of solid precipitate scores equals 1. Write a symbol equation for this reaction. Explain, in terms of electron transfer, why bromine is the oxidizing agent in this reaction. Look for 2 comments. Sulfide ion, sulfur ion, loses electrons 1. Not sodium sulfide. Bromine accepts them. B. Iron and steel in the presence of water and oxygen form rust. What type of reaction is reaction 1? Oxidation 1. Not redox. Deduce the name of the colorless gas mentioned in reaction 1. Hydrogen H2. Not H. What is the name of the iron compound formed in reaction 2? Iron 2 hydroxide, ferrous hydroxide. IV. Balance the equation for reaction 3. V. Explain why the change FeOH2 to FeOH3 is oxidation. Oxidation number or state or valency increases, electron loss Fe2 plus to Fe3 plus 1. Not gains oxygen. Vi. Explain why iron in electrical contact with a piece of zinc does not rust. Sacrificial protection or zinc is sacrificed. Zinc corrodes, not iron, or zinc corrodes, therefore iron doesn't. Not just zinc rusts. Zinc is oxidized in preference to iron. Zinc reacts with oxygen and water in preference to iron. Zinc more reactive or electropositive than iron. Zinc forms ions more readily than iron, or zinc loses electrons more readily than iron. Electrons move on to iron. Iron is cathode or zinc is anode. Ne3. 0620_W09_Ms_31. 3. An important ore of zinc is zinc blender, ZNS. How is zinc blender changed into zinc oxide? Heat or roast or burn in air. 1. Need both points for mark. Write a balanced equation for the reduction of zinc oxide to zinc bicarbon. ZNO plus C. Right pointing arrow zinc plus company 2. Or 2ZNO plus C. Right pointing arrow 2 zinc plus CO2. Unbalanced only. 1. B. A major use of zinc is galvanizing. Steel objects are coated with a thin layer of zinc. This protects the steel from rusting even when the layer of zinc is broken. Zinc is more reactive. 1. It loses electrons and forms ions in preference to iron. 1. Zinc corrodes, not iron. 1. Not zinc rusts. Zinc loses electrons and forms ions. 1. The electrons move on to the iron. 1. The iron cannot be oxidized, or it cannot rust, or it cannot lose electrons. 1. Zinc electrodes have been used in cells for many years. One of the first was the Daniell cell in 1831. Give an explanation for the following in terms of atoms and ions. Observation at zinc electrode. The electrode becomes smaller. Zinc atoms change into ions, the zinc dissolves. 1. Copper 2 ions change into atoms, becomes plated with copper. 1. When a current flows, charged particles move around the circuit. What type of particle moves through the electrolytes? Ions. 1. Which particle moves through the wires and the voltmeter? Electrons. 1. For the distinctive smell of the seaside was thought to be caused by ozone, O3. Ozone is a form of the element oxygen. A mixture of oxygen and ozone is formed by passing electric sparks through oxygen. Suggest a technique that might separate this mixture. Explain why this method separates the two forms of oxygen. Diffusion. 1. Different mixture or ozone molecules heavier than oxygen molecules. Or different densities or oxygen molecules move faster than ozone molecules. 1. Not oxygen is lighter or ozone heavier. Or fractional distillation. 1. They have different boiling points. 1. B. Ozone is an oxidant. It can oxidize an iodide to iodine. What would you see when ozone is bubbled through aqueous acidified potassium iodide? From colorless solution. 1. To brown solution. 1. Explain in terms of electron transfer why the change from iodide ions to iodine molecules is oxidation. Loses electrons to form iodine molecules. 1. Must be in terms of electron transfer, not oxidation number. Explain, using your answer to be why ozone is the oxidant in this reaction. The electrons are accepted by ozone. Or it is an electron acceptor. C. It is now known that the smell of the seaside is due to the chemical dimethyl sulfide. Draw a diagram that shows the arrangement of the valency electrons in one molecule of this covalent compound. Use X to represent an electron from a carbon atom. Use O to represent an electron from a hydrogen atom. Use filled circle to represent an electron from a sulfur atom. Correct structural skeleton. 1. COND4BP around both carbon atoms. 1. 2 BP and 2 NBP around sulfur atom 1. Note marks 2 and 3 can only be awarded if mark 1 has been scored. II. Name the 3 compounds formed when dimethyl sulfide is burnt in excess oxygen. Water, carbon dioxide, sulfur dioxide.